try and always start with that label pointing upwards, just so that it's consistent. I have to make sure this is in contact with the lever. That's in contact with the lever. Okay, we can kind of tell by the rhythm that it's 2 to 1, can't we? Okay, we've given that 3 runs now, I think. So now we just tried that one on its own, and I predict it'll go faster because the energy isn't being shared anymore. All the energy can go to that. That was obviously faster, wasn't it? I'll do 3. I think 3's enough, isn't it? Why do I keep making that dopey mistake? I'm getting like Gary. Okay, now try that one now. Gary thinks this should go twice as fast. I say it should go 1.4 times as fast, ideally, but it'll be better than last time, I'm sure. I don't think that's going to be twice as fast. I don't think it's going to be 1.72 times as fast. I think it's going to be closer to 1.4 times as fast, but I don't know yet. I'm recording this in 120 frames per second. Right, so that's all I can do, isn't it, for the moment. I might as well just, while I'm at it, just try a couple of other things, other objects, just to see what happens.
On second thoughts, that can wait. I don't want to overload people with information. I did do it. I did do lots of different objects, but I won't show it just yet. Save that for another day. Okay, so we're going to start doing frame counting. I'll do it like this. Gary didn't understand last time I did this. So I click forward 1 frame at a time like this on my keyboard. So I count from, they've both been released, haven't they? So let me just go back. Oh yeah, I count from when the lever stops moving, don't I? So I count from when the lever stops moving. Yeah, that's the one. So I count from here. Okay, so first of all, I will count the 2 mass on the right till it hits the tin plate.
1, 2, 3, 4, 5, 6, 7, 8.
Actually, there's a better way of doing this. Hang on, go back.
1, 2, 3, 4, 5, 6, 7, 8.
See, the way I did it, Gary, last time was so I could use this feature here. I simply did this. I simply put a cut there, and I get rid of that. Now that counter there has gone to 0, so by the time we get to each various point, it will tell us the exact number of frames. Instead of us having to count it, literally, Gary, we just use that. So it wasn't a cheat, it was automatically counting for us. So I can just advance to it. Can you see where I've circled in yellow? Can you see it going up? It's counting the frames for us. Oh, testing. Right, so we're back on. Half an hour later, back on. What happened was the tripod holding the camera and microphone I'm talking into toppled over, pulled the mouse on the floor, mouse broke, had to open the mouse, do the fiddly job of mending it, cut off some wire and just reconnect all the wires, slip it all back in. Didn't want to go back together. Anyway, got there. Right, so I'm going to start this section again. So we're on 0. Now we advance forward till the half mass on the left. Click forward until, yeah, so that was 48. So we mark 48 there. And the 2 mass there. That does look like it's halfway there already. Advance forward to that crashing into the plate. Yeah, so 97. 48, 48 would be 96. So move on to the next one. I'll still leave that there because it's useful to remind you what you're looking at. The frame count, that's on 0. We advance forward till the... Oh, we have to find a proper 0 point first, don't we? So when the lever stops moving, that's it. So I'll do it 1 frame at a time. Back, lever's not moving now. There. So I put a cut there, ripple delete. And so again, that's still on 0. Okay. Now we advance forward until the 1 mass clashes with the plate. Do it 1 frame at a time. I'm going back and forth just to be sure. Yeah, I think it's 49. Yeah, it's 49 this time. Okay, so 49. Again, the half mast here looks halfway across, so it looks on target. So we advance forward till that clashes with the plate. Let's do it one frame at a time again.
1, 2.
99. Okay, folks, so that's near enough spot on, isn't it? 2-to-1 ratio, snapshot. Move on to the next one. Find the point where the lever stops moving on this one. Get rid of those numbers. One frame at a time. Right, so that's our starting point. I put a cut there. Ripple delete that. So once more, that is back on 0. It's ready to count for us. So we don't have to count, because humans make mistakes, don't we? One frame at a time. I'm not even looking at the numbers when I'm doing this. 48 this time, okay? 48. Again, that looks halfway across. And one frame at a time. 1, 2. I don't know why I keep counting. The thing does it for me. I have to do it till the template stops moving, because the template, when the left one crashes into it, it might just shift it a little bit. So the second copper roller hitting it just puts it back again. So we have to check that it's gone all the way. And 99, you see there? So 99. 48, 48 would have been 96, wouldn't it? Is that right? Yeah. So 99, that's a bit faster than it should be. Okay, snapshot. Yes, just to remind you, now it's just the 2 masts moving on its own. Gary thinks the 1 mast will go twice the speed of the 2 masts just because it's on a lever twice as far away from the fulcrum, and it's half the mast. I mean, it won't. Find the starting point when the lever stops moving. One frame at a time. So that's the start point. So I put a cut there. Get rid of that. So once more, the frame counter is 0'd. And now it'll count for us if we just drag across. Previously this was doing about 99, wasn't it? Let's do it one frame at a time. Just going back a bit. Yeah, you can tell when it stops turning. I suppose it's turning it because it's rolling. So rotational momentum is keeping it rolling. So you can't judge if it's still rolling. Call that right, I think. It's hit the template, hasn't it? And that's 57. Previously that was 90 and the 99 sort of region, wasn't it? Looking at the red tape on it to count when it stops rolling, I suppose you could say 58. Not much difference, is there? Well, that's that for that one, isn't it? Next one. Find the point of the lever. No longer moving.
1 frame at a time.
That's that. Put a cut there. Ripple delete that. Once more, the counter is 0'd.
Counting now.
1 frame at a time. I'd say that was it, 55. Didn't spin that time, did it? That was go number 2. Third go.
Well, I'm afraid I had to re-record the third go and the 3 examples of the 1 mast because there was an extra video missing. I didn't realise. The one you've just been watching ended abruptly on the third go, halfway of it rolling across. So I couldn't find the video. In the end, I just thought it's just easy to reload the original file into HitFilm and video it again. And it wasn't that hard in the end. I don't know why I was so reluctant to do it. It just feels like a pain in the arse having to do it. So that's why there's an interrupt. That's why you're looking at my ugly mushy. First task, I have to find the point where the lever stops moving. So I go through one step at a time, don't I? Oh, there we go. Yeah, the lever stopped moving. Go back. Forward one. Right, the lever stopped moving there. So that's the point where I have to put a cut here. Ripple delete that. Go back to the start. And now you can see the frame counter circled in red as 0. So we're measuring from here. Step through, you can see it rolling away. And the counter going up. This is where the other video ended for some reason. I don't know why. Never found the other video. So we count from. I'm trying not to count if it's rolling
I'm trying not to count it, so let's go back because it was rolling a bit there. I want to just count from the point where it doesn't roll, but it stopped. It's rolling there, so go back one. Not counting the rolling. Okay, so it's hit there and it started to roll. So 57 then. Okay, so that was the last of these runs. Next it will be the one mass. This is the two mass, isn't it? Next it will be the one mass. So find when the lever starts moving. Okay, that stopped there. That's it. Okay, so we call that 0. Put a cut there. Remove that. Go back to start, and you can see this is on 0 again. Okay, so now we can click through. You can see it's not skidding. It's rotating. That's rotating there, isn't it? Yeah, so I'm just counting from when it's not rotating. That point there, so 40. I seem to remember they all came out at 40 last time, so that's good. We're getting the same results. 40. Snapshot. Click through it. Till the lever stops moving against the lever stop. There, that was it. Go back one. So there, put a cut. Triple delete. Counter is at 0, and now we inch through it. Click through it. Go back. We don't want to count the rotation, do we? No. Yeah, so no rotation there. So that's 40 again, as expected, really. Snapshot. Third one. Waiting for the point when the lever stops moving. Back. Back one. And that's it. Make a cut there. Triple delete. Go back to start. So the counter is zeroed, and we count from here. Click through. Not skidding. If it's either stopped or it hasn't, that's rotating, isn't it? So it's that point, isn't it, when it's hit the 10 tray. So 40 again. Snapshot. And that's it, isn't it? I was going to do some slow-mos, but what's the point really when I think about it? The slow-moing it was to enable Gary or anybody else to frame count more accurately at 30 frames per second. So I thought if I slow it down 4 times, well, fuck that for a game of soldiers. I'm being honest here, so that's all that's necessary. Fuck it. Okay, and that's it then. Video redone. 48, 97, 49, 40, 99, 48, 99. That was that session done. 2-to-1 ratio. 48 plus 49, 48 again, equals 145, 7, 99, 295. So divide that by 145 equals 2-to-1 ratio, 2 exactly, near enough, 2.0, yeah, equals 2-to-1 ratio, okay. Well, at least that verifies that it is a good experiment, even if there is rotational energy. You can't think of the right word. Right, so it still worked out to perfectly a 2-to-1 ratio. So next, 57. Let's ignore the second figure because I put it in all of them, but it just confuses matters, doesn't it? It actually stops dead at 57. Rotates a bit. One more. Not worth counting, is it? 57. The next one was 55. The next one was 57 again. And then the final test, 40. The next one was 40 again. And the next one was 40 again as well. Okay, so now we want some averages, don't we? Calculator. 40, 40, 40. Well, 120, we don't need a calculator for that, do we? So 120, they add up to 57 plus 55 plus 57 again equals 169. 169. Gary claims it'll be a 2-to-1 ratio. 169 divided by 120 equal 1.4x. I'm sorry. I can't help laughing. I wish the camera was on me now. My face must be fucking a sight to see. How fucking wrong can Gary be? I'm sorry, Gary. I honestly don't really want to rub it in. And if I do, yes, I'm a liar in that regard. Only because you're a fucking cunt, though, mate. I mean, seriously. I know that you're not going to accept this, even though it proves you absolutely fucking catastrophically wrong, shockingly wrong. And everybody else, when the experiment's been done diligently, been proved fucking shockingly right. I'm surprised. I thought it wasn't going to come out right. No, well, I knew it was going to come out right, but I didn't know it was coming out. I didn't know. Once again, this is the third time this has happened now. Exactly fucking 1.4. 1.4. Well, that's it, isn't it? Gary, you've been proved wrong for the fucking third and final time, as far as I'm concerned. I don't know what's wrong with you that you can't accept the bloody obvious. That this 1.4 figure just keeps coming out again and again and again for the perfectly rational reason that it's fucking right. Anyway, no point me labouring the point anymore because you're never going to get it. This argument is never going to be settled until there's somebody honest on your side that you trust. That's what's missing in this debate. Honesty on your side, not on our side. I declared the results wrong last time. They came out at 1.69 last time because it was the left the teeth in Steve. My imaginary teeth. Last time the half mass, that's half of a pool ball, that did skid, and as Michael Fowle explained, that makes it go faster, not slower, because it's not in contact with the ground to slow it down. It doesn't have the rotational momentum. It's skidding along, just like a skier goes faster than a bike downhill. And that's why these results keep coming in. Perfect, Gary. When we do the experiment as diligently as we can. Right, so this is a very cluttered view of the experiment, so let's simplify it. So now you can only see the experiment itself and a bit of the editing window. Now I'm showing you the start and end points that we measure between. And just a reminder that these are the nicely machined parts that Gary always promised and demanded of others, but never delivered himself. In the bottom left corner you can see the cut tool and the stretch tool, so I can explain later how I ensure slow-mo footage is exactly halved or quartered or eighths or sixteenths, etc. So Gary can reliably frame count, and you can see in blue this is a typical clip that I'll be slow-moing, and a reminder that I've verified the weights accurately, unlike Gary. Here I'm pointing to 0 on the lever measuring tape, which is 18 inches from the fulcrum. That's the launch point. So when that launches the object, it covers twice the distance in the same amount of time. At this point, launches the 2 mass at half the speed, covering half the distance. 9 inches from the other point and 9 inches from the fulcrum. Now you can see them in context. Now I'm pointing to the quick release pin that Gary demands, and now you can see that in context too. And here you can see it in operation.
Again, lock and load.
And it's exactly 9 inches from that point to the fulcrum. Same image, but now in context. Because Gary thinks everybody's lying to him. 9 inches to the fulcrum, 9 inches to the fulcrum, 9 inches to the fulcrum, and the spring at the far end. Note the center line on the roller lines up perfectly with the 9 mark, and a foam rubber pad used to make sure that I align it exactly the same every time. The circle of blue dots in the middle represents a heavy mass lever stop. It looks like the lever has already stopped against it because of the camera being a bit too far forward, but it's not. That's why the lever is still at an angle. If you don't have a very substantial lever stop, then the lever will flex at the far end and give it a slingshot effect, giving a more than 2-to-1 ratio effect. It ended up being more like 2.5-to-1 ratio. I know so because I've done it. I've made that mistake before. I'd not showed it because it would have looked like I was cheating in the spring experiment. So that's why my original experiment said new bar in the middle, because I'd replaced it with a steel bar to try and make sure it didn't flex, and employed a lever stop. In that case, it was a screw. The whole reason it says new bar is because I was being honest about changing the lever before recording this experiment. The first one I ever used was slightly flexible, so it overshot, giving a greater than 2-to-1 ratio, making the half mass go even faster, compressing the spring even more. I was being honest, but you couldn't see that. In fact, Gary didn't even recognize it was a lever back then, 2 years ago. Everybody else did, so he probably just pretended to be confused just so he could moan about me supposedly just pushing the stick hundreds of times, then cherry-picking the results, the few that went in my favour. What a load of old codswallop. He lied to his own supporters, basically. Notice the screw serving as a stop for the lever instead of a heavy mass. This confused Gary as well, the fact that I'd swapped the red one from the left to the right. He pretended to think that it was a different experiment. It's gone all blurred because I was having to magnify it and swap the left to the right and the right to the left so I could put them right next to each other so that you've got a better comparison for the distances involved. That's the only reason I did that. The reason they look thinner and all squashed up is because, again, I was trying to compress the image into a manageable space. Your total lack of effort in 3 months is shameful in view of the amount of pontificating you've been doing and slandering that you've been doing of good people. Fuck off. So now I'm pointing to the 1 mass there, 18 inches from the fulcrum, and there's the 2 mass, 9 inches from the fulcrum. Now I'm pointing to the frame counter and also the start and end point again. Just a reminder that it's recorded at 120 frames per second for accuracy. I've verified it at 2 times velocity, verified that at 1 times velocity, but that only applies where it's launching these 2 particular objects at these particular places on the lever at the same time. When it's launching them singly, it launches them at different velocities, and that's the whole point of this experiment, Gary. Okay. And because the masses have a 2-to-1 relationship, their velocities end up having a square root of 2 relationship when launched independently by the spring, because it gives the half mass the same amount of energy as it gives to the 2 mass, but it can't make it go the same speed because That would be breaking the laws of conservation of energy, wouldn't it? That's why it goes slower than you think it does. It only goes 1.4 square root of 2, Gary. But they still work out as having exactly the same kinetic energy as each other when you apply the kinetic energy formula. If you had 3:1 ratio masses, 3 times the distance away from the fulcrum, the lightest one would go square root of 3 times the speed of the heavier one. In other words, 1.732 times. But they still work out as having exactly the same kinetic energy as each other when you apply the kinetic energy formula. If it was 4:1 ratio masses, 4 times the distance away from the fulcrum. The quarter weight one would go square root of 4 times the speed of the 4 times heavy one. In other words, 2 times. But they still work out as having exactly the same kinetic energy as each other when you apply the kinetic energy formula. In other words, you've got to quarter the weight, quarter the mass, to make it go 2 times faster. Yeah? But they still work out as having exactly the same kinetic energy as each other when you apply the kinetic energy formula. That was borne out in my 31 runs of that cart experiment, yeah? And that was also using the same frame counting method I used here that you disputed. It does work semi-automatically. You just have to set it to 0 and let it count the frames for you so you don't make mistakes. So I don't make mistakes, because I do make mistakes, as you well know. But this isn't one of them. Remember, Gary, it wasn't until the weight of the cart was reduced from 4 kilograms down to 1 kilogram in 100-gram stages that it finally managed to go 2 times faster, launched by the same spring in every case. Yes, there may have been little tiny imperfections, but they were tiny imperfections. 1 or 2 things slid about a little bit. Very, very tiny imperfections. Very slight error. But you don't point out those errors in Toadie's experiment, do you? So you've got to be fair and judge both experiments fairly. And mine was a far more accurate experiment. If you dispute that, then you're being dishonest with yourself. Because Toadie even suggested I do that experiment before he knew I'd done it already, which only goes to show how little attention people pay to which only goes to show how little attention people pay to experiments they should see before they criticise. I mean, nice though the man is, he had no qualms about trying to humiliate me by making up a story that I'd used a nail instead of a proper bearing in one of my experiments. This is a proper bearing. Oops. It's fallen on the floor. But that is a proper bearing. The only way we can make it oscillate is if I do put a pendulum on there so that the centre of mass is below that rotation point. These are just plastic tubes which are conveniently the right size. Now it'll oscillate because it's weighted below the centre of gravity. If you put an extra weight like that on the bottom of a car wheel, it would do the same thing. This is your lever, Gary. A car wheel would just do the same thing. I thought you said it wouldn't do that, Gary. How could that have possibly been a nail? Still got that thing stuck on me glasses, I see now. Been walking around with that on for days. This is a proper bearing. But that is a proper bearing. He said it was a nail. Total fabrication. And there I'm just pointing out that the table has been properly levelled and proved to be level, just to make it easy to make sure that the rollers aren't skidding. I put red, white, blue stickers on the rollers. Now you've said that you want to see skidding. I can do that for you, no problem though. She'll get exactly the same result. It's all recorded in one take, if you wanted to see it in one take, no editing. I'm going to edit it for this episode because it's boring otherwise, isn't it? I've also done some random unknown masses so that you can calculate what the weights of them are using your MV. But I doubt very much you can do that. Just a reminder to the cowards that this is a reproducible experiment. Any of you can do this if you have a mind to, if you're not bone idle. Think how many dozens of experiments people like me and Minders, Marbles, etc. have to do. You asked for details, Gary, and that's what you've got. So let me explain to you. I put in some notes for you. Here goes. We've got a 99-gram aluminium lever, 15mm by 10mm by 1.5mm U section, 664mm long, including the tape measure and placement guides, ensuring accurate placement, dead center. The camera lens, positioned too far forward, distorts the perspective a little bit. So stop, moronically claiming that I misposition things off center. Here, Gary failed to recognize parallax error. Parallax error. The camera was a bit too far left. I'd moved it a bit left to show the left wall when I'd started the experiment. But this creates the illusion that the can edges are not lined up with the center line. And if you don't know what parallax error is, parallax error can also be an issue when reading moving coil meters from slightly the wrong angle if you're not directly above the meter. But anyway, they were lined up properly. You should also note that I've made the objects an identical shape, so nobody can complain this time about them being different shapes. You'll find something to complain about, of course you will. That's your job, sort of. Right, and finally, I've provided slow motion footage so even Gary and other empty heads can check that computers really can count frames more reliably and quickly than us humans. Gary foolishly claimed otherwise last time, so I have to show the cretin every simple thing that he pretends not to understand, just to fake an argument for his fans, who are gullible fools to believe a word he says. Oh, and importantly, the lever height has been made to push the centre of mass, Gary. The centre of mass. I better make that very clear, hadn't I? The lever has been made to push the centre of mass. Looks a lot when you put it on one page. If I don't go through it step by step, Gary would never absorb this information, because it involves reading and thinking.